Today, our keynote. Please welcome Marek.
Thank you. Let me check if you can hear me. I think you can. Raise your hand if you can. I don't see people in the back raising hands. All right. Welcome, everyone. Thank you, Boris, for introducing me. My name is Marek. I'm a software engineer at Google. I work in Warsaw office, so Europe, not so far away. I joined Google about 4 years ago. I started working on cloud functions. And this is the reason I chose this particular topic for this presentation, which is going serverless with Google Cloud, because I was actually a part of the serverless story at Google. And the good thing is that this serverless Google Cloud Functions was actually built in Warsaw, so Central Eastern Europe, this region. And I think this is something that we all can participate in. So the technology is not only built in the US or Western Europe, but it's also built here. Google has had the office in Warsaw for maybe 10 years now. And we already have quite a few interesting projects, one of them being Cloud Functions. Then we have a lot of projects about virtual machines. We have autoscalers for Compute Engine. We have autoscalers for Kubernetes. We have a team working on Kubernetes. We have a team working on Cloud Console. A lot of interesting projects. And it's just happening here in the region. But this talk is not about what we do in Warsaw. I just took this opportunity to advertise our office a little bit. This talk is about serverless. How many of you have heard the term serverless? Oh, it's so nice. Most of the people, half of the people. OK, so for those who haven't heard, I will briefly introduce what serverless is. But I will go a little bit deeper, so I hope even those who heard about it can learn something more. And then I will tell you how you can build with serverless on Google Cloud. There are a few different options that you can choose. It's not only Cloud Functions. We have App Engine. We have Cloud Run. You can use serverless also on your own clusters, Kubernetes clusters with Knative. But to build efficient applications, you actually need to know how this all works, because probably you want to optimize. In serverless, you pay for how much time it takes for your code to execute, so the faster your code executes, you actually pay less. And finally, I will touch a little bit what's beyond serverless code that you can execute. I will be talking a little bit about serverless databases, maybe serverless CI/CD pipelines, things like that. So let's jump into the first topic. What is serverless? And let me start with an example. Imagine you are building a service for mobile phone users, but the old-style mobile phone users without mobile applications, without Android applications, just text messages. You want your users to send text messages to some number and then get a reply message with a joke. Very simple. Everybody can use it. I think it's a great user experience because you don't have to learn some advanced technology. You just use text messages, which a lot of people still use. So think about how you build this application. It's probably very simple. You have to set up some server. You have to handle requests from this mobile carrier provider that will receive the messages, and then you reply. You get some joke, and you reply with it. When you think a little bit deeper, you may want to set up some front end so that it receives the text messages, put it into some queue. Maybe then there are backends that actually get the joke and send it back to the user. In this case, in this way, you have some independence of the front and back end can scale independently. If you think about having a lot of users, you need to have this auto-scaling with many backend servers, maybe many front-end servers. So it gets more and more complicated. Even though the initial problem was so simple, just send the joke, you may end up with this kind of architecture with multiple virtual machines that you have to manage. And that's actually a problem, because if you have those virtual machines, you have to set up new ones if you need more traffic, or set up some autoscalers. You have to manage updates for the operating system. And this kind of architecture, even though the initial problem was very simple, quite quickly evolves into something complex. I'm actually exaggerating now. It won't be so complex for this problem, I guess. But it may become. If we add more features to your app, maybe you want the text messages to reply with some other things, not only jokes. And if you have this kind of complex architecture, it's very easy when it evolves to become a mess. And you end up with something like this. And you don't really understand where are the servers, what are the jobs, what are the queues, what is all this about, and how to actually update one component without breaking any other. And the thing that you wanted to do is just this. Response.message, like send a message with a new joke, a random one. And this brings me to the principle of serverless. To solve the problem with this complex architecture with you having to maintain the machines, scalability, you have to pay for the machines even if they are not in use. The key principles is that you don't manage servers with serverless. Then you don't think about scaling. The platform scales the workload, scales the capacity depending on the workload. If there are many people asking for a joke, this should be transparent for you as a programmer. You just want to serve jokes. And finally, it's quite useful to be able to pay only when your code runs. Imagine that if you have people just from Europe, they will be probably asking for a joke in the evening or in the afternoon, not during work, hopefully. And so why would you maintain the servers during that time? Even if there is just one server, why would you pay for it? Wouldn't it be better just to pay in the evenings where people execute your code by sending messages? And this actually can be brought even further if you do some some similar phone application where you allow people to vote during TV programs for the best actor or for the best person in the program. Your application runs only for 2 hours a day or maybe 2 hours once a week, and then normally you would have to shut down the servers, then set it up before the event occurs, then shut it down again. It's a lot of work. And with serverless, you can just pay when your code is executed. Very comfortable. But is it possible? And I hope to convince you that we are already there. So let me go back into what are the components of an architect, so what are the components and the architecture layers of an application. On the very top, we have hardware, where you physically have a machine that you have to buy in a store. Probably nobody does it anymore. Usually people rent machines from the cloud providers. They just take virtual machines. Then you have the operating system, where you have to manage updates. You have to choose which operating system you use. Over that, you have application runtime. For instance, if you write applications on Node.js, you have to install the Node.js runtime, or maybe some web server, Apache, Java, virtual machine. And then you have your application itself. So this is finally where we get to your job as software engineers. I guess maybe not all of you, but a large part of you are software engineers. And then we have the application, where you really code what your application does. Sometimes the application consists of many different components, so it has many different functions. And functions are the smallest building blocks of your application. So in case of our joke app, this is just the function to send back a message with a joke. And with serverless, it's actually possible to write only on this level with serverless cloud functions. I will be talking about other serverless platforms a little bit more as well, but with the simplest architecture with cloud functions, you think just about functions. So if you remember the app that we wanted to build at the very beginning, this is what we wanted to do, and it's possible with cloud functions. This is a function. But if you need more, you can actually build your entire application in the serverless fashion. If you have maybe some dependencies between the different functions in your app, you want to have your app as a single component, it's still possible with serverless. At Google Cloud, we have a service called App Engine. And even further, if you need a very complex system when you actually deliver your own maybe web server, maybe you want to have more flexibility than the cloud platform provides, maybe maybe you want to write your web server in Haskell. So then it's possible to actually run containers together with the application runtime, application itself, and multiple functions, also in a serverless fashion. And this is what those different layers of architecture look like. And we will actually focus on this without the hardware, without the operating system, just on the application runtime in containers. And the system in Google Cloud is called Cloud Run. You run serverless containers. You pay only when the container serves the traffic. Then there is App Engine with the application and functions. And finally, the simplest one is just Cloud Functions. So how can you build with serverless? Let me go a little bit deeper into the 3 different serverless systems that we have in Google Cloud. And let me start with App Engine. Let me start with App Engine because I think conceptually it's probably the easiest to understand. You don't have to understand how to connect different functions with each other. Maybe this functional architecture is maybe not so simple to understand from the very beginning, even though it's quite simple to program. So let's start with App Engine. App Engine is here, just to remind you. A simplest App Engine application is like this. So as you can see, you write the entire application code. This is Node.js. And inside the application, you have the web server somewhere here, listening to, I don't think it's visible, listening here to your incoming traffic. And then you have handlers for individual URLs inside your app. So you can write one application with multiple functions inside. So that's an example for Node.js. There are also other languages provided, supported, that you can use. With application, you can focus on the code. As you saw on the previous slide, there was just application code. And then the platform will take care of automatically scaling your application depending on the workload. It will handle failures. You don't have to worry about that your server dies and you have to set up a new one, or maybe have some automation that will set up a new one. And App Engine is a pretty advanced service. It's the oldest that Google has in the serverless area. And this is why it has very interesting properties, very interesting support. For instance, support for versioning. When you want to release a new version of your application, you don't want to just put all your users onto the new version because you're not sure if it works, right? So normally you want to create a new version, slowly migrate the traffic to the new one, check if there are no errors, if the users are still happy, and then once everything works, just migrate everybody else. So App Engine has this versioning, traffic splitting, and of course it has out-of-the-box security. You don't think about security. We handle that for you. I mean, you have to think to some extent, of course, because your application can just expose too much to users because you designed it this way, but you don't think about the platform security. So App Engine is mostly for web developers. If you want to move from your physical servers to the cloud and make it scalable and easier to manage. App Engine was actually created in around 2008. This was long before the word serverless was coined. So this is a quite old service. The initial goal for the team that built App Engine was to actually increase the velocity of even internal application developers at Google. And then this has become popular even outside of Google and was some kind of basis for serverless. Intrinsically, App Engine currently serves 300 billion of requests per day. This is quite a lot if you compare it to some other numbers, let's say Wikipedia, based on publicly available numbers. I think both numbers, this one and the Wikipedia ones, are from maybe January this year. Wikipedia serves around 300 million web pages per day. So even if one web page, well, one Wikipedia page is about 10 requests, which you can actually measure easily yourself, App Engine still has 2 orders of magnitude more traffic. So it's a large service overall. And of course, App Engine serves your application, so it's your users that execute those 300 billion requests per day. Next one, Cloud Functions. Cloud Functions is the project that I had the opportunity to work on. Almost from the very beginning, when I joined the company, the project had started maybe 3 or 4 months before that. So I was almost from the beginning, and we managed to bring the product from the early phase up to general availability with many features available, so it's ready to use. How many of you use Cloud Functions? How many of you use Firebase Functions? Okay, Firebase Functions and Cloud Functions is actually the same product. It's just different brand, just for Firebase users to make it more natural, maybe easier to understand that this is a product actually dedicated also for Firebase. Functions are here, just the last part of your application. The easiest program, the hello world, in Cloud Functions is very simple. It's just one line of code plus the signature of the function itself. Like in any other programming language, you write the main, and then you write this hello world that prints some hello statement. And when you deploy this function, it automatically gets you all the configuration that you would need to serve traffic, HTTP traffic, serving these hello serverless fans. So you get HTTPS with a certificate automatically provisioned. You don't have to worry about getting the certificates and having this padlock in the web browser. It's scaled automatically, and you are built up to less than a second. So you are built for every 100 milliseconds that your function runs. So if your function is very fast, it's very cheap, actually. And you don't pay when the functions are not executed. And of course, the platform provides you with logging support, error reporting, metrics, but it's the same with App Engine as well. And you get a domain under cloudfunctions.net. You get a URL under cloudfunctions.net domain. But functions are more than that. Functions are not only about web responses, web applications. Functions are also, and maybe even more, towards events. With functions, you can connect different cloud services in the way that something happens on one service, and then a function is triggered to respond to that. For instance, imagine you have an application that lets users upload pictures to cloud storage. When somebody uploads a picture, your application has to generate a thumbnail and put it somewhere else so that it's shown on another web page. And it's very easy with Cloud Functions. You don't have to monitor cloud storage to find new images. All you have to do is to register a Cloud Function that will respond to the event of a new picture appearing on cloud storage. And the function can then download the image, generate a thumbnail, upload it somewhere else, done. Very simple. So cloud storage, it's just an example. There are other services, like Cloud PubSub, the message queues. But most importantly, Cloud Functions are very well integrated with Firebase. Sometimes it's called Firebase Functions, or Cloud Functions for Firebase, maybe that's a better name. And in Firebase, you can react to changes in the database. So imagine you have a database where you put different data from your users. For instance, when a new user registers, you can register a record in the database. And with Cloud Functions, you can actually, when this new record is registered in the database, this can trigger a function that will send a welcome email. And this is very convenient because you don't have to have another server component, or you don't have to actually do it from one place. If something crashes in the middle, like you write something to the database, then your process crashes, the user doesn't get the welcome email, so they maybe don't even know the password, and they are registered. So with Cloud Functions, you can separate those different concerns and actually develop them independently, release them independently, and make your architecture easier. Cloud Functions can be very useful when your code has to respond to events, like in the case I provided. And it's very simple. You just write code, you click deploy. You can use the web console, the UI for the cloud to write your functions, but you can also use your favorite editor on your local machine and use some command line tools to deploy it. The tool is called gcloud. Easy to learn, easy to reason about, just easy. You remember the joke application that we wanted to have, right? I presented some difficult architecture, maybe it was too complex for this problem, and we wanted to have just one line. In fact, with Cloud Functions, you can have a fully operational application like this. I think this should more or less work. So for the message provider, for the SMS provider that will notify your application when the new SMS message arrives, we can use Twilio, where you can register a mobile phone number, and then your application gets a webhook. For the webhook, you can register the URL of Cloud Functions. And then whenever a new request comes, you actually ignore the request. It doesn't matter what the user wrote in the message. You just don't use it at all. So the REQ parameter is not used at all. But you just generate a new joke and send it back to Twilio in some particular format. And then Twilio will forward the response to the mobile phone number that sent the message asking for a joke. Very simple. It's not one line. It's a bit more, but it works. And now let's move to something more generic, something a little bit more complex, but this gives you a lot of flexibility. Serverless containers. With Cloud Functions, you are limited to a few runtimes. You are limited to either Node.js, I think, Golang, Python. There is an alpha version of Java, or maybe it's already in beta, I'm not sure. And if you want to use something more complicated, you cannot easily do it in functions. But you can do it with Cloud Run. You can build your own container and then run it in the same serverless fashion as you would use it with Cloud Functions. And that container will also be automatically scaled. This container will also be automatically, the failures will be automatically handled by the platform. So it removes a lot of responsibilities for you. And more importantly, you don't have to have a cluster. Cloud Run is here. So functions, application, and application runtime, this is your responsibility. And the operating system and hardware is on the platform. So you don't manage machines, you manage containers. I already explained that it's more generic, you run containers, but also with those containers, if you run it on the cloud, you can easily start a container on your local machine and have a local developer experience where you immediately test what you wrote. You can also run those containers on your local on-premise cluster with an open source framework called Knative. Cloud Run is compatible with Knative. Whatever you run with Knative, you can run with Cloud Run on the cloud. And you can run on Knative on your Kubernetes cluster. Very convenient. An example in Cloud Run is slightly more complicated than with Cloud Functions. As you can see, there are 3 components. Actually, this one of the components should also be present in the previous slides, but I just skipped it for simplicity. You already also have this Node.js, Express.js application that handles incoming web traffic and handles results using some handlers. You have package.json that specifies dependencies. This package.json should also be specified for Cloud Functions and for App Engine. Whenever you use some dependencies, you have to specify what the dependencies are. So that one was a little bit oversimplified, but it didn't change so much. But most importantly, with Cloud Run, you have to write the Docker file. So it's a little bit more effort, but on the other hand, it gives you a lot of flexibility. So this Docker file installs Node.js, copies the package.json file, installs the dependencies, copies the local file like this index.js into the destination container, and finally, when the container starts, it executes the start command, which is here, which will start Node runtime with this index.js. So that's an example of an application using Cloud Run. Why Cloud Run? Any language, any library, any binary, very flexible. If you need more flexibility, go for it. If you need portability to run your workload on-premise, on your own cluster, go for it. And it's built on this open source project called Knative, also built by Google. Just to recap, we had those 3 different levels of abstractions in services, serverless services on Google Cloud, Cloud Run, App Engine, Cloud Functions. And now let's try to look inside how this all works. What does it mean that it's all serverless? So where is the code executed? It's serverless. Where are the servers? Of course, the servers must exist. The servers are just owned by Google and managed by Google. We run everything, all our jobs at Google, on some shared infrastructure called Borg, but it shouldn't really matter for you. Unless you are really interested, you can search on the web for information about Borg. It's very interesting how it's built. We run on Borg everything, including search, YouTube, Gmail, and so on. And of course, we cannot easily run your code because your code is not trusted. We cannot trust that your code will not try to maybe send some emails in Gmail, or maybe it will try to change the search results. We have to be protected against it. And we have to protect your code, your untrusted code, from interfering with some other code of another user. So we sandbox it. We sandbox it using gvisor. It's a sandboxing technology based on containers. So there is a hint for you. All the different services that I described, serverless containers, serverless applications in App Engine, and serverless functions in Cloud Functions, they are all internally using containers that are run using gvisor on our shared infrastructure. But this is luckily all transparent for you. This is just information for you so that you more or less know how it works. If you need to read more, just learn about gvisor, but it shouldn't affect the way how you write code. The code should just work with proper isolation, security, and so on. But what's important about containers? Containers are long-lived. And I think this is the most important information that I would like you to learn and remember from the session. So what does it mean to be long-lived? When your code is executed, when somebody calls an sends an HTTP request to your container or your application or function, it's served in some serverless container run in our cloud, in Google Cloud. On our infrastructure, actually. And then when another request comes, we'll put it into the same container. So in this sense, this container is long-lived. This instance is long-lived because it handles multiple requests. We don't shut down the instances after one request is executed. So it's very important to understand and remember about it, because this means that if you have a running instance, the next invocation will be actually faster because it doesn't have to do all the initialization, right? The next invocation will be can use some results that are cached from the previous invocation. So this is a way for you to optimize. Next, those instances are auto-scaled. If there is more traffic that is necessary, we'll start another instance. So there'll be some startup time that will take a little bit longer, and then the new instance will keep on handling new requests. And by the way, in case of Cloud Functions, one instance handles just one request. In case of Cloud Run and App Engine, usually they handle multiple requests at the same time, so there is concurrency involved. And finally, instances are dedicated to your particular application or to your particular functions. This means that they scale independently. And if, maybe to give you an example, if you have two functions NAB, if your function A is executed on an instance, then there will be just function A executed there, no function B. In this way, you can more easily reason what's going on in the container if you have out-of-memory errors, for instance. You just have to look into function A. So these instances are long-lived, live across many invocations, auto-scaled, and dedicated. What is the execution environment? It's very easy to learn it yourself. You have a container, you can execute whatever you want. You can execute whatever you want using Cloud Run because it's a content containerized environment, but you can execute whatever you want also in Cloud Functions. Even though you write functions, let's say in Python in this case, you can execute any shell command. So you can execute maybe ls to see what you have in your directory. You can execute whoami to see what permissions you have inside the container, and so on and so on. That's a very interesting exercise. If you are already an experienced user of Cloud Functions, just try it yourself. Maybe you will learn something more. How is the code executed? You know that it's executed on instances, But how does it work? I already touched it a little bit with this cold starts and hot starts when the new instance is started and when it's reused. But let's go a little bit deeper, or maybe let's recap again how it works. So we have instances for a particular function. Let's focus on functions maybe for simplicity. In this case, 2 instances are busy. One of them is idle. And when a new request comes, it will go to the idle instance. We'll reuse it. In this case, this invocation is faster because the instance is already there. And then the instance becomes busy, and when a new request comes, it will not have any instance to run on, so we will spin a new one. And this is called a cold start. A cold start means that it takes a little bit longer for your invocation to run because the infrastructure has to set up a new instance to run your code and do some initialization, including initializing your code. And then the instance becomes busy. Then when the request finishes, it becomes idle. And it can be idle for some time, but after a longer period, we'll actually shut it down. And we shut it down because we want to reduce costs for the cloud provider. This running instance actually consumes some memory. So let's look more closely into the cold start. What happens when there is no running instance and we have to add another one to handle the traffic? And I mentioned that it will take longer. So why would it take longer? There are some overheads. First of all, we have to find out where the new instance should be started. We have many machines in Google Cloud, many physical machines, and we have to choose one to run the container, right? Then the container has to be initialized on that machine. That includes downloading some files. Then the language runtime will start. So in case of Node.js, we'll start the Node.js process. And those 3 first things are actually entirely on the cloud provider, on us. You don't actually see it. You don't even have the influence to speed it up. But I think it's good, because it's not your responsibility. This is the infrastructure that we provide for you, and we should be responsible to make it fast. Actually, in case of Cloud Run, the language runtime startup, this is something, and maybe also some part of the container startup, this is something that you can influence, so you can actually make it slower or faster. But in case of Cloud Functions, it's just the last part that you can optimize, loading the code, initialization of the container. So what to do if the calls are too long? If you want, well, too long probably means that they take maybe 300 milliseconds instead of 100 milliseconds. It always depends on the scale of your application. If your application is very complex, the call start will take longer because it will take longer to initialize your global variables, to load the dependencies. So what you can do, exactly that, remove unused dependencies. Why would we load something that we don't use? Do lazy initialization. If your code has multiple different things that it manages, maybe in every invocation you don't need all the data to be initialized. So in this way, you can speed up the initial invocations for the cost of maybe doing some additional stuff later. But overall, the average probably will not change, but you will make the experience better for the users who hit the cold starts. So it's worth doing. But I think the most important idea is to split the code into smaller pieces. Because if you have a large piece of code, it probably has many dependencies. And if you split it into half, very often you will actually, each part will have smaller amount of dependencies, smaller number of dependencies. Probably not half of the dependencies, but it will be just faster. And those independent pieces can scale independently, which is also an advantage, and can be released independently. You can update one piece without updating the other piece. On the other hand, hot starts, when your instance is already available, gives you also an opportunity to optimize. Your instance is already available. There was a previous invocation on this instance. So maybe it's possible to cache some state or some computations that you've done. Maybe you have downloaded a large machine learning model to handle the previous request. And why would you download it again if it was just a couple seconds ago or milliseconds? So cache the state. In particular, you can cache network connections. Establishing a network connection, especially if the system is very remote, takes time. So very often it's better to have a persistent connection and just send packets whenever there is need. It always depends on where the system is and how long it takes to initialize this network connection. So you probably measure it before doing the optimization so that you don't go into the wrong direction. But it's just an idea. And if you can move objects to global scope so that they don't get recomputed on every invocation, if they don't need to. Finally, how do I pay? I think this is very important to understand. Let me go back. This is very important to understand because this actually influences how you build your application and how you optimize. Because it's certainly possible to optimize costs. If your code runs faster, you will pay less. So let's do it one by one because the payment model actually differs. In case of App Engine, you are billed for the instance time. App Engine automatically adds instances and removes instances very, well, aggressively maybe. So you will not pay for so long, but you pay for the instance being up and running. There is an opportunity to exploit here because if you pay for instances being up and running, you can actually execute some code even after the instances finish handling traffic. It's not the best idea because that execution can be interrupted in any way, in any point of time, but it's certainly possible. I actually discourage doing that, but it's possible. Maybe more importantly, if you pay for the instances, you can actually configure your application to have maybe fixed number of instances. If you have those instances always available, you will have to pay for it, but you don't have problems with cold starts. Sometimes it makes sense. It pays back. Sometimes you need it. In App Engine, as you can see in the picture, App Engine can handle multiple requests in a single instance at the same time, so there's multiple concurrency. So you actually expect to have not so many instances, not as many as if it was single concurrent. You can actually configure the concurrency level for your application, depending on what you need. For Cloud Run, however, you pay only when the code is executed. When the last request finishes, we freeze the container, and your code will no longer run. And we freeze our container, for instance, because we don't want you to mine Bitcoins in the period where we don't bill for, in the gray period in the picture. So with Cloud Run, this is entirely serverless. As I described, you pay only when your code runs. It may probably be cheaper in many cases, but please compare prices just for your particular use case because there are many different options. And finally, Cloud Functions. With Cloud Functions, you have one request per instance at the same time. So this means that if you have two concurrent requests, you have to have two instances running at the same time. So you have to pay for those instances. So this may suggest that the Cloud Functions are actually more expensive because you need two instances, you pay for two instances, while in Cloud Run you pay just for one. But there is good news here. Cloud Functions can be much smaller. You can configure a Cloud Function to have 128 megabytes of memory, and this is very little, but this can be sufficient for just single request. And with single request, concurrent request, it's actually easier for you to reason about what's going on in the application. You don't have the parallelism, the concurrency, some race conditions. It's just easier. And Cloud Functions may not necessarily be more expensive, as I mentioned, because the size can be smaller than in other cases. And you can see that in the picture. For instance, the whole blue area which we built for is probably less than in case of Cloud Run. So we already know what serverless is, how you can build on Google Cloud Platform with serverless, how serverless works underneath, how to optimize it, how to optimize the time for requests so you know how to pay less because you pay for the execution time. And also your users will be more happy because they will get faster responses. And what's now beyond serverless compute? Is that all, the three services that we have serverless? I think it very much depends on the definition of serverless. But just to give you some ideas about what serverless can be, you remember the three principles. Pay only when your code runs, so when you use the service. have auto-scaling, and don't manage any machines. And you can imagine having a serverless database when you don't manage the database itself, the machines. You just have infinitely scalable database that you can just store data in. Of course, you will pay for the storage because you use the storage. But then if you have no queries to the database, you don't pay for it. You just pay for the number of requests that comes. So for instance, you don't pay for the request at night if there is no traffic. And we already have such databases like Firestore, Datastore. You may imagine serverless CI/CD pipelines where you want to do some integrations based maybe on some events. And we have Cloud Build, which can start a virtual machine invisible for you actually, and run some code and then shut it down. And you pay only for the time that it takes to execute our code. And there are many other options that we can claim are serverless. Very often, the serverless is also referred to as cloud-native architecture, because we are doing some stuff that is not really related to the code, to machines that we run, to something that we normally run on-prem, but we have some new way of architecting our applications on the cloud. So what are the next steps for you? Try Cloud Functions. Cloud.google.com/functions, you will find a lot of resources. I know that half of you already tried, which is great. You can try App Engine as well if you want. If you are experienced user of Cloud Functions, do that, just to see what the differences are. Definitely try Cloud Run, because this gives you a lot of different options. And for sure, try Cloud Function with Firebase. Functions extend Firebase a lot, and Firebase is a great tool for developers, especially for mobile developers, web developers. Do some code labs. We have a lot of code labs on codelabs.developer.google.com. And if you search for Cloud Functions, you will probably find this one. And apply for a job at Google once you learn all of that. We have very interesting projects in Warsaw, and we're looking for experienced engineers to help us building the cloud. We are actually, in Warsaw is the European hub for cloud. I think we are the only European office where the cloud is built. And this is all. Thank you very much. And I think we have... We don't have so much time, but I think we can take a few questions.
Yeah, of course, obviously. So the thing is that I promised Marek that every time we get quite many questions in the DevFest. At the moment, we don't have a single question written in the Slido. Marek, is not because of you, it's because we haven't shared our link properly, in a proper way. So if you want me to also put it over there on my screen, otherwise it's Slido DF, meaning DevFest, BG, meaning Bulgaria, 19, meaning this is the year now, and it's WC, it's Web Cloud. It's so easy, you already remember. Please feel free to ask any questions so that we can reach to Marek. The idea is here that we don't go around the table, the room with the mic, but if you don't feel like and you cannot find Slido, it's also good to shout out your question, and Marek will be happy to answer this one.
So let's try one live question first. Oh, there is one live question.
I'm interested in how to share what's the developer experience. So I set up my computer, how do I develop so that I can do some coding on Cloud Functions?
OK, so the question, just to repeat for the camera and for those of you who haven't heard, the question is, what is the developer experience for those serverless platforms, especially for Cloud Functions? How does it work for a developer? You sit at a machine, you code it. So there are, the easiest developer experience is just go to console.cloud.google.com, which is the cloud console where you can access all the services. And then there is a text editor when you can edit function source code. If you are new to Cloud Functions, you can just click deploy because there is a default function written for you. Then, if you are more experienced, you your own editor, and you have the files where you wrote it, and then you deploy it using command line. But I think you are also asking how do you test it, because that's probably most important. So with functions, these are functions. So it's very easy to test it as any other function, right? What you need to do is to make some mocks for all the services that you use, like in every unit testing. I think that's possible. And executing on the cloud should not be much different than executing on your local machine. Okay? Does it answer the question, more or less? Mm-hmm.
For example, just the way I'm going to have hot roles and put my ID into my browser and see everything. Just the same experience in going to the cloud and seeing the result.
So the question was whether there are some plugins for IDEs, the most popular IDEs, that would not only allow you to edit the code, but then deploy it and so on. I'm not sure because I'm not the user of Cloud Functions, to be honest. I was on the development team. I think there are none, but I may be wrong. Do you have time for another question, or shall we finish?
I definitely want to, even to extending a little bit and delaying a little bit the schedule, I prefer to have a couple of more questions. The first one goes the following. Does Cloud Run use container registry or some kind of container caching?
Container registry or caching? I think it uses container registry. But I have to mention that I was on the Cloud Functions, not on Cloud Run, so I'm only vaguely familiar with the developer experience on Cloud Run, but I'm almost sure container registry. So we have Google Container Registry, a service at Google Cloud. For sure that can be used with Cloud Run. I think it can work with any other container registries, but I'm not sure about it.
The next question is there any way to see how many users were hit with a code state of a function? And the question is regarding users, but maybe also regarding sessions, so both of them. Is there anywhere to check how often does it happen to your application?
Could you repeat the beginning?
Yes, so I'm interpreting the question, I can also read it. In console, is there a place where I can check how many users were hit by a code state of a function?
Oh, okay, cold starts.
And it's a user, and I'm also adding a question about the session.
Cold start. Yes, yes and no. So firstly, no. So there is not such metric where you can see where the cold start is. And yes, it's very easy to add it to your code because all you need to do is to increase the metric in the global state when your function is initialized. You can just increase the metric. Or if you add a log statement into the global scope, this log statement will be logged only during cold start because this is the only time where the global scope is executed. So it's not provided by default by the platform, but it's extremely easy to be added.
If Marek doesn't quite answer any of your questions, feel free to add another one in Slido. There was the one in line.
Raise your hand and
that's also fine, yeah.
Let me clarify.
The last one over here in Slido is Cloud Run only meant for standard web server technologies like Express and Flask, or could I run any kind of a program?
Cloud Run?
Yeah.
A Cloud Run can be for any technology. I think the important part that you have to remember is that Cloud Run is for HTTP or for HTTP traffic. So you start executing things inside the container based on HTTP requests and responses. I mean, when there are responses, the container finishes executing the request, and then when there are no active requests being handled, we will freeze it. So any workload, but kind of based on HTTP requests.
Mm-hmm. How much time would it pass for an instance to be idle, and then it will be killed and starts again?
This very much depends on, this can change. We don't give any guarantees. From my experience, it can take very long. You can actually try to, can you try to measure it? It's not, maybe not really so easy. I would say, no, maybe I would not say. Yeah, just check it yourself. It's definitely long. It's not that it will kill it immediately. Probably if there are too many idle instances, it may be even faster, but we'll probably keep a few ones around.
Okay, we're done with the questions in Slido. If there is anybody else that want to add additional one in the audience, otherwise, we get in the otherwise. So otherwise, we thank Marek once again for his session. Thank you very much.